For the second half of this unit, you're going to be using completing the square to rewrite quadratic equations that are in standard form in vertex form. We've gone in one direction. We've gone from vertex form to standard form. This is how you go from standard form to vertex form. So this is an example to write in your notes. Please make sure you have this equation written in your notes. Notice that instead of equal to a 0, now our equation is equal to y. So this is a quadratic function. It's written in standard form, and we would like it to be in vertex form. Remember, vertex form is the one with parentheses and a squared, so that's why it's going to be an ideal situation for completing the square. Vertex form looks like this: y equals, there's an a, that tells you whether the parabola is opening up or down. And then there's an x minus h plus k, and then your vertex would be h comma k. All right, so the first thing we're going to do is we're going to move the constant. We're going to move the 11 to the other side of the equation. So we're subtracting 11 from both sides. On the left-hand side, we have y minus 11. And on the right-hand side, we have x squared minus 8x. Notice that y and 11 are not like terms, so we didn't combine them. Okay. Next thing we're going to do is we're going to complete the square. So I'm looking at x squared minus 8x. I'm going to go ahead and make my box. The x squared will go here. I want that negative 8x to be divided evenly between these two boxes, so it would be negative 4x and negative 4x. We always divide that negative 8 divided by 2 to figure out what goes there. Then we kind of work on the outsides of the box, so this would be x, and this would be negative 4 in order to make that multiply to be negative 4x. This would be x, and this would be negative 4. That means that since negative 4 times negative 4 is 16, that in order to complete the square, we would need to add 16 to the right-hand side of the equation. Anytime you add a number to one side of the equation, you have to add it to the other side of the equation as well. So we're going to add 16 to both sides of our equation. When we do that, we get y, and then these numbers are like terms, so we'll add them together. We get plus 5. And then on the other side, we have x squared minus 8x plus 16. None of those are like terms. But we've already done the work to know what that would look like in factored form, so let's go ahead and write that. So we have y plus 5 is equal to x minus 4, and since they're both dimensions are x minus 4, we don't have to write them both side by side. We can just write squared. Okay, we've completed the square. Now we're going to move the new constant back. I'm pointing out that that's not the same number it used to be. It used to be a negative 11. Now it's a 5. So I'm going to go ahead and move that. So I'm going to subtract 5 from both sides. And I have y is equal to x minus 4 squared minus 5. Notice how it now looks like a quadratic in vertex form, and so I can easily see that the vertex is at 4 comma negative 5. The x coordinate is here, but we change the sign, and the y coordinate is here, but we keep the sign the same. I know a lot about this quadratic right now. I know that it faces up because a is 1. And I know that it is exactly as wide as the parent function. I know that it's been shifted to the right 4 and down 5. I also know the y-intercept is 11 because I know what it looks like when it's in standard form. Okay, I'm going to encourage you to pause the video and try these two in your notes so that you have an example in your notes of rewriting a equation from standard form to vertex form. So pause now and return when you've finished. The first thing I did was subtract 3 from both sides of the equation. So I had y minus 3 equals x squared minus 2x. The next thing I'm going to do is complete the square with this box that I've written here. When I complete the square, I divide this negative 2 by 2, so I have negative 1 and negative 1x, which means that my factored form would be x minus 1, and that the number I have to add to complete the square is 1. So I'm going to add 1 to both sides. Now I have y minus 2 is equal to this, but that's also equal to x minus 1 squared when it's in factored form. The last step would be adding 2 to both sides, so I have y is equal to x minus 1 squared plus 2. The second problem, the first thing I want to do is subtract 25 from both sides of my equation. So I have y minus 25 is equal to x squared plus 6x. Then I'm going to go to a box so that I can complete the square for x squared minus 6x. When I divide 6x into two equal parts, they're both 3x. And so that means that my constant that I have to add is 9. I'm going to add 9 to both sides of my equation. So this side of the equation becomes y minus 16. And the other side of the equation is x squared plus 6x plus 9, which is the same thing as x plus 3 squared. Now I'm going to move my constant, so I'll add 16 to both sides of the equation. My final answer is y is equal to x plus 3 squared plus 16. And that means my vertex for this problem is negative 3 comma 16. My vertex for the other problem, I didn't write that one down, but my vertex for the other problem was 1 comma 2. Okay. Sometimes when you're doing problems that you're rewriting in vertex form, a, which is the number that tells you whether the parabola opens up or down and how wide it is, isn't 1. And so there's one extra step when a is not 1. So we're going to go through that process for this problem. So this is a problem about astronauts. I don't know if you know this, but you can fly an airplane. If you fly it in kind of an upside-down parabola shape, there's a moment in there, there's a certain amount of time in there when the people inside of the airplane feel what zero gravity feels like, and that's how we train astronauts. Okay, so they're asking what is the maximum altitude reached by the airplane. That's going to happen at the vertex, but my problem is that this is in standard form, so I'm going to rewrite it so that it's in vertex form so I can see the vertex easily. So here's my equation. It's a equals negative 5t squared plus 80t plus 900. 9,000. First thing I want to do is subtract 9,000 from both sides. So I have a minus 9,000 is equal to negative 5t squared plus 80t. Okay, this is the part that's different. The next thing we're going to do is we're going to use negative 5 as a GCF and factor negative 5 out. What that means is that we would like this to look like it looked like before we distributed a negative 5. So negative 5t squared would be, if I divide by negative 5, would just be t squared. And then 80 divided by negative 5 would be negative 16, and that would still have a t on it. Okay, the part that we're going to complete the square is the part inside of the parentheses. So we're going to go ahead and draw our square. This corner will be t squared. These two corners have to be equal and they have to add up to negative 16. So I'm going to put negative t, 8t, and negative 8t, which means that this would be t and this would be negative 8. And that makes this box 64. The problem is, if I add 64 inside the parentheses, I'm not really adding 64. I'm adding negative 5 plus 64 because I want it to be inside the parentheses. So I need to add over here negative 5 times 64. So when a is not 1, you have to make sure that you're accounting for that when you add your when you complete your square. So the left-hand side becomes a minus, I need to know what 64 times 5 is. Yeah. So it's negative 9,000 minus 320. And then on the other side, I have negative 5 times t minus 8 squared. 1 minute, please. I'm going to combine like terms over here. So I have a minus 9,320 and then the last thing I'm going to do is add the 9,320 to both sides of my equation. Okay, it's asking me what the maximum altitude is. The maximum altitude is going to be the y-coordinate of the vertex, so the maximum altitude is 9,320 meters. And the maximum, it also asks what time does it plane reach its maximum altitude. That's going to be the t-coordinate. So it reaches its maximum altitude in 8 seconds, because that's the x-coordinate or t-coordinate of that parabola vertex.
I've got something.
Hold on. Okay, we're going to do one more of this type of problem so that you have another example of these. This might be one that you write in your notes. Okay, so first thing I want to do is move the 105 over. Also, feel free to have a calculator. You don't have to do these in your head. You don't have to do the math in your head. So I'm subtracting 105. There's no real math there. And then I don't want to have the 7 involved, so I'm going to divide everything by 7 on the left-hand side. So 7, and then parentheses. I'm undoing distributive, so 7x squared divided by 7 would just be x squared. And then, this is what I'm saying, you could have your calculator out, but 168 divided by 7 is 24. Okay, this is what we're doing our completing the square on, so we're going to go ahead and draw our square. So this would have to be x squared. We want the 24x to be evenly distributed, so it would be 12x and 12x. So this would be x, this would be 12, and this box would have to be 144. Okay, I'm going to add 144, but inside the parentheses, which means that I need to multiply it by 7 when I add it to the other side. So I'm going to add 7 times 144 to the other side. Again, grab your calculator. You don't have to do that math in your head. So y minus 105 plus 1008 is equal to 7. Factored form would be x plus 12 squared. Now I'm going to combine 1008 and 105, so I get y plus 903. And then I'll subtract the 903 over, so I have y is equal to 7x plus 12 squared minus 903. The question is asking what's the minimum value. The minimum value will be the y-coordinate of the vertex, because this is an upward-facing parabola, so the minimum value would be down here. So the minimum value would be negative 903. All right, this whole unit was about completing the square, and we used completing the square to solve quadratic equations. We also used completing the square to rewrite standard form equations into vertex form equations.